harmonics. So what they say is you take the LO, one is going to be omega 1 is directly going, and divide omega 1 by 2, and you mix omega and omega 1 by 2. So when you add, it becomes 3 omega 1 by 2. When you subtract, it becomes omega 1 by 2. So I am generating subharmonics. Subharmonics means fractional multiples of your in the omega 1 frequency. So if you use this as your I and Q signal, then you will have your signal at omega 1 by 2 and 3 omega 1 by 2. Okay. So using subharmonics, we can also modify this architecture. So let us consider the arrangement where oscillator and frequency by 2 are mixed. So in this transmitter, using such an LO waveform, the output would contain equal power at both the carrier frequencies. You can see the output power is same. They are same at both the carrier frequencies, omega 1 by 2 and 3 omega 1 by 2. So thus half of the power delivered to the antenna is wasted. Therefore, the power transmitted to unwanted carrier frequency corrupt channel in other bands. Since you're transmitting the same information in two frequencies, you're wasting the power, and this may affect the information in the other part of the channel. That is going to be a serious drawback of this model and direct conversion transmitter. So one component must be suppressed, or you have to filter the other thing. Either suppress omega by 2 or filter 3 omega 1 by 2, which is going to be the high frequency component. So we can go for SSB, which is called a single sideband mixing or single sideband suppression. So I'm going to multiply the quadrature phase of omega 1 and omega 2, and I'm going to subtract, which is going to be ensuring that one signal is cancelled out and the other signal is going to be reaching the transmitter. So in addition to the image subband, the harmonics of the input will also corrupt the output of SSB mixer. So see here, you take 2 by 3 omega 1, divide by 2, you get 1 by 3 omega 1, and you use that for mixing. So 2 by 3 and 1 by 3. So addition will be omega 1, subtraction will be 1 by 3 omega 1. So that is going to be given as input to your mixers for the in phase and quadrature phase. And then I'm going to add them on power amplifier and send it. So finally, I'm going to send only one signal at omega 1. So it is going to suppress the other frequency, so that the power and the other requirements are going to be completely saved in our architecture. Okay, since the carrier and LO frequency sufficiently different, it is free from injection pulling and suppresses the carrier sideband omega 1 by 2. And it sends the signal only at the frequency omega 1. Okay. So this architecture has two drawbacks. One is the spurs at 5 omega 1 by 2 and other harmonic frequencies may prove troublesome. We have seen about spur. So whatever local oscillator frequency harmonics you are going to have, you are going to call it as spur. So that at higher order frequencies of your spur, there might be some issues. So the LO must provide quadrature phases, a difficult issue. So you have to always have a quadrature architecture to overcome this issue, which may not be possible